So our review for exam 3, just like to go over a few things, the big picture type of thing, to see if you remember some of this stuff. Lauren, okay, we have 2 R's. I could even be giving you more R's on the exam, right? And there'll be an equation sheet with all this stuff on there. But we use one gas constant in particular pretty much all the time. Which one was it? 0.821. And why? Why do we use this one pretty much all the time?
Because we always use liquid pressures like chem.
Exactly. Right? It tells us what units to use for everything. That's why we pretty much use this R all the time. Okay. Monica, we have PV equals nRT, then we have this one. What was a strong hint in telling you which one to use? Yeah, if it had double, yeah, if it had 2 pressures or 2 temperatures, or double what you're looking for, like she said. Here's the milliliters. What's going to be the new milliliters? Right? Good. Okay. Ideal gas law, PV equals nRT revised to kind of like rearrange it a little bit. Victoria, and we had PM equals dirt. What was little d? Density. And it had to be Alyssa in what units? Otherwise this whole thing wouldn't work. It had to be in certain units. Kimberly, you remember? Grams over liters. Right? Then everything else would work out. Frankie, big M in that equation, PM equals dirt, is what? The molar mass. Molar mass. And molar mass is always in what units? Everybody. Grams per mole. Yep. Okay. And then we had a couple equations for little q. What was little q? Jesus? What was little q again? What was it called? Anyone remember? Heat. It's heat. And it's always in what units, Gilbert? Kilojoules, or it could be in joules, big J. Okay. Now, when you're calculating this heat, Amy, it's really helpful if you know what these guys are. S and big C, because it'll tell you what equation to use. What was the name for big C? What was it called? Victoria, it's heat capacity. Good, heat capacity. How about little s? Teresa, what was little s? What was this one called? No, don't go back to the don't go back. If you don't remember, you don't remember it. You want to help her? Specific heat. Specific heat. Okay, specific heat. And okay, that's how a couple ways to get little q, heat. And then we had oh hey, before we keep going here, when did we have to use this? Table of vapor pressure of water. So they gave us a vapor pressure of water, Alyssa, then all these different temperatures. When did you have to use this? Yeah, when it said it has to do with a gas, the pressure of a gas, yeah. But in the word problem, what's the big hint that says you have to use this table? You're close. You're halfway there. It has something to do with water. You're collecting a gas over water. Whenever they say that, right? Because then the gas you're collecting isn't only the gas you want, but it's also water. So you have to subtract out the pressure that's due to water to get the pressure due to that gas you're interested in. So when they say collecting a gas over water, you have to use this table. Okay. Well, Kimberly, isn't that so nice? We're collecting a gas over water, use the table. What do you do with the table? Exactly. Did you hear her? The temperature that they say it's, I don't know, 19 degrees. So you got to subtract out 16.5 millimeters of mercury from the pressure they gave you because it's too high. You want the pressure due to whatever the gas is, not the gas and water. So you got to subtract it out. The pressure's too high. Okay. Subtract the pressure they gave you minus the pressure in the table. Because you want the pressure due solely to that gas. Okay. It's pretty much, if you like an equation, it's pretty much this one, right? This is the gas we're interested in, and that one's water. So to get the pressure of the gas you're interested in, just take the total minus the water. So that's kind of the equation, if you like equations better. And then we said there were 3 ways to get the enthalpy for a reaction. And I thought this was the hardest way. I don't know about you, because it was two parts. You had to get the number of kilojoules. Then you had to get the number of moles. Divide the two, and then you got the enthalpy for that chemical equation. But Gilbert, how did we get these kilojoules very often? Do you remember? How did we get it? There's a hint on this list of equations. Does anyone see it? There's actually 2 equations. Use the heat equations. Very often, you had to use this one or you had to use this one, because that kilojoules is Q, right? So there's your Q. So pretty much that's what we had to do a lot. We realized, just remember the units. Kilojoules is heat. Okay, so that's our Q. And then how do we get the number of moles usually, Lauren? How do we get the bottom part? How do we get the bottom part? Yeah, they're never going to tell you the number of moles. They're always going to tell you the grams, and then you got to convert it into moles. Boom, divide it. Good. Okay, and then there's another way to get the enthalpy for remember, thermochemical equation is where you have reactants going to products, and then you have this delta H. So that's what we're talking about, the delta H that corresponds to a chemical equation. Yeah. Well, I'm not going to give you. I give you all the equations. There aren't equations here. This is the only equation I'll give you. All right, and it's just going to be the equation. It's not going to be. Right, I don't know if I'll even give you the equation, because this products might. We'll get to number 3. Let's talk about number 2 first. Okay, there's another way to get the enthalpy for a chemical equation, for a thermochemical equation. Hess's law. They had to give you what, Victoria? They had to give you the final equation, and what else did they give you? Good, you hear? They gave you a bunch of chemical equations and the heats for them. Then you had to flip them, multiply them by 2 times a half, right? And add them all up to get the final equation. That was Hess's law. Okay, the one that Dreeks does, I'm saying that I'm not even sure if I'll give you the equation for, because it's pretty straightforward. If I gave you the formula on the quiz, then I'll give it to you on the exam. I don't remember if I did or not. But it's not too bad. What do? What do they have to give you, Amy, for this type of question? To find the enthalpy for a reaction. Not the heat capacity. What was this called? Standard enthalpy of formation. They had to give you the standard enthalpy of formation for every single compound in that reaction. And then you add them all up for the products, subtract them all out for the reactants, and you're done. They have to give you all the standard enthalpy of formation, kilojoules per mole for every single compound. Just add them all up for the products, subtract them out for the reactants, and you're done. Okay?
What's the S symbol?
Formation. Standard enthalpy of formation. You're actually the heat involved in forming it from its elements. Okay, so those were the 3 ways to get a thermochemical equation. And then we had our like our quantum numbers, N, L, and L, just an introduction to it. I would just know that table. Because if you can know the table, you can know any homework question, any exam question I'm going to give you, right? So I would know that table. I'd probably practice it too. We have some at the end of this. So since we have our help session, I'd like to just start at the beginning, and that way whoever shows up at the help session, more than likely that we pretty much got through the same section of this review. Okay. And plus this is the oldest stuff, so most likely this is what you forgot. Using the Dumas method, a sample weighing 71.6 milligrams gives 3.84 milliliters of nitrogen gas at 23 degrees Celsius and 785 millimeters mercury. What is the volume of nitrogen at STP, which is 0 degrees Celsius and 1 atmosphere? It's got to be something up here. Christine, you got an idea? She says, is it this one? Any takers? No? Here, PV equals nRT. What do you think, Jesus? P equals nRT. Okay. But let's say whichever one you pick, you write it down. And if it doesn't work, then you try the other one, right? Now, what Christine said is the easy way to go. Why did you say?
Because of the I2.
There's 2 temperatures and stuff, right? This is actually an easier way to go. This way is actually easier. But
you have to convert the milligrams.
we could also do it the PV equals nRT way. Because they said 3.84 milliliters of nitrogen gas, so these are just in the wrong units.
Yeah.
But the point is, let's just put a check mark by it. We know this. Do we know P? Yes. Do we know T? Yeah, so right? We know this, P, T. All we need is little n. Do we know little n? Yeah. Convert 71.6 milligrams to what units? Moles. Do you know what the gas is so you can find the molar mass? Nitrogen. The trick to doing this is, what's the formula for nitrogen gas? Is it N or N2? It's N2. Just realize that. But I like Christine's way better. It's one step, straightforward and easier. Can you see why? Do we have to worry? Over here, with PV equals nRT, we have to convert because R is in that equation. Volume has to be, everybody, in what units? Volume has to be liters. Pressure has to be ATM. Temperature always Kelvin, no matter what the equation is. Over here, just make the units the same on both sides. Right? Except temperature has to be Kelvin, always.
I just thought they were saying because it says IE0 or whatever. I thought they were
Okay.
saying that it's constant.
No, IE is, in other words, what STP is, in case you didn't remember remember it. And since you can't Google on the exam like I would like to. So, let's try it. Either try the original PV equals nRT way or try the P1V1 or T1 equation and solve for the volume. Or the ATM to millimeters mercury. They just have to be the same units on both sides. You could.
What's the number?
There's 1 ATM is 760 millimeters of mercury. No, Jerixa, I don't think I give you this. I'm not so sure I'm going to give this to you. This equation, because looking at the quiz, I didn't give it to you. And this is where all the equations kind of piled up on here. So I don't think I should say that. And since I didn't convert to liters, my answer is going to be in milliliters. What'd you get? Oh, so you're solving for V. So the 273 is going to have to go to the top, right? Yeah, and this 760 is going to have to go to the bottom. Yeah, that's what I got, 3.6. Somewhere around 3.66 or 3.65 or so.
So you just left here.
And I left it in milliliters, since they didn't specify. It's the easiest thing to do.
Oh, I see. Oh, yes.
If you got it, try the next one. I think it'd be the easiest, because they want the molar mass. And they gave you pressure and volume and all that stuff, so it has to be an ideal gas law type of question. You're just missing what to use PM equals dirt? D. So how are you going to get D? You got to get D first. Remember what its units were. Someone said it. So do that. Get the grams divided by the liters and get little d first. But in liters, which would be 0.345. Yep. Christine's talking about using PM equals dirt. That's one way to do it. The other way is to use PV equals nRT and find little n. Then take the number of grams over n to get molar mass. But I think this way is easier, it's just one step. Kind of, right? You just have to get what first? Density. And you remember, Monica, what were the units for density? Grams over liters. So I say this way is easier, but get D first. The number of grams over the number of liters. And then you're ready to use PM equals dirt. The number of grams? Oh, 3.65, yeah, milliliters. Mm-hmm. Liters. Into 6.6667 or something. Now, once you get little d, you're good to go. Just watch your units on everything. What did you get? 178 or so. Amy, did you get 178? Anybody get around 170 something? Okay, right around 178. Okay, now you get points off though if you don't have the units. Grams per mole. Molar mass is always grams per mole. That's close enough, right? Just depends how many digits you carried. Somewhere around there. Really close to 180. Keep going if you got it. If you didn't, just ask. I'll be glad to help you. Well, that's, yeah, that every problem solving is always like that. So follow a logical order, logical sequence, and understand the equations you're using. For example, if I'm going to use anything that has capital R in it, I've really got to worry about units because everything has to match R.
Okay.
But if I do not have capital R in it,
Okay.
just make the units the same on both sides.
Okay.
Or you're always safe, Jerixa, if you're not comfortable, just always put it in ATMs.
Yeah.
It's so fast. So it doesn't, you're not really hurting anything.
It's because I did, and then I got another answer. That's why I started
Oh, okay.
Because when you convert the other one to,
Millimeters of mercury.
yeah, you just get 1.032.
So who has a game plan for 78? Use PV equals nRT. Now, Christine's been on a roll. Is anyone going to argue with her? No? PV equals nRT, yeah. All right. What are we missing to use PV equals nRT? We're missing N. Good. Where are you going to get the N? 50 grams of NO. It's just the wrong units and the wrong compound is all, right? It's the wrong units and the wrong compound. The compound has to be what? What's the chemical have to be to plug into PV equals nRT? Yeah, what kind? What has to be? Oh, has to be the oxygen, right? Because oxygen is the gas. What volume of oxygen gas? Yeah, so the volume of oxygen gas, the pressure of the oxygen gas, all right, the temperature of the oxygen gas, and has to be the moles of the oxygen gas. So just, you found little n, it's just the wrong units and the wrong compound. So how do you get to the right units, which is moles, and mole bridge? There you go. I know, you better ace that test. Use the mole bridge. And that's how you're going to get from the wrong units and the wrong compound all the way to the moles of oxygen. Now you're going to have to use the molar mass too, right? Because you can't use the mole bridge until you're in moles first. But we know all this stuff. What's that? 50 grams of NO has to be molar mass, so you have to add it up. The 1 always goes with the moles. Well, it depends on where you make your units cancel. The grams have to be on the bottom, so moles has to be on top. And you want to convert to moles, so that makes sense.
So when you're going from that NO, you go and add 1 nitrogen, 1 oxygen.
To get the molar mass of NO, yeah.
And then on top you put 1 mole of, what is it?
Yeah, molar mass always looks like, so 14 and 16 is 30, right?
Mm-hmm.
So you could write it as 30 grams of NO for every 1 mole of NO, or you could write it as 1 mole of NO
Equals 30 grams.
over 30 grams of NO.
I wrote that one.
And this is the one you want.
No, yeah, that one.
Otherwise the units won't work out.
Yeah, so then after I did that,
Then you're ready for mole bridge.
yeah, so then I put one, I know, one mole and
Mhm.
then bottom, and then 4.
Mm-hmm. You got it. Well, the 4 goes with the NO. The 5
Yeah.
goes with the O2.
The 4 mole and and then
Just keep going. You get it.
okay, but now I have to go to you said
You want to stop at moles of oxygen. Like, look at our units. You want moles of O2. And that's what your little n's going to be. I'm stealing Victoria's answer.
and then you go
Alright. And then we're ready to plug it into PV equals nRT. Oh, that's nice. For once they gave us the pressure in atmospheres. Jesus, did you get an answer for this one? These guys got 24 and a half. You get 24 and a half? Shoot. Yeah. I think that's three people got around 24 and a half. So I think that's it. And the units are liters. Do your moles to be 2.08? Okay.
and then the R, and then the temp.
421 Kelvin. No, temperature's 308 Kelvin.
Where? The temperature? Yeah, 148 plus 273 is 420.
Look at 148. Temperature's 35 degrees Celsius.
What did I read? Oh,
Okay. So let's try this one.
I went over here. I got
Hmm.
this one.
Okay. Get a chance to read it. This is what they want. Grams of ammonium nitrite. That's our answer. Someone has a game plan. Do you have a game plan? Go for it. You've been on a roll. You haven't been wrong yet. PV equals nRT. We don't have much choice, right? We really don't have any choice. They're giving us volume and temperature and pressure. You don't have any choice. PV equals nRT. Now, how does that help you, though? Using the equation PV equals nRT, how are we going to get grams of ammonium nitrite out of that? Good, you're halfway there, Teresa. You're just missing the specifics. We're going to solve for little n.
Oh, so you.
Little n is going to be the moles of what? Is it the moles of ammonium nitrite?
No.
It's the moles of N2. Okay. So how do we go from the moles of N2 to grams of ammonium nitrite? Wrong units, wrong compound. How do you go to the right units of the right compound? Mole bridge, in combination with probably some molar masses in there, right? Mole bridge. Mole bridge. Okay. Now, remember, though, one of these variables is off since you are collecting over water, right? What do you got to do? Use that chart, right? Now, our P needs to be in what units in this problem? ATMs, right? And so we're going to have to convert this KPA to ATMs. Or what do you want to do? Right? You have to get the right P.
Oh, that's okay.
And you said we got to subtract out.
Oh, sure. So.
Got to subtract out 23.8. She said right here.
Yeah, because if you go to 25.
So you have 97.8 kilopascals, and you got to subtract out 23.8 millimeters of mercury. Can you just subtract those two? No, you gotta. Right, they're in the wrong units.
So then would you divide the 97.8 kg by 100?
There you go.
And then that.
That's what I would do. Just what Lauren's saying. See, she's going to convert both of these to ATMs. She said divide the 97.8 kilopascals by the 101.325, and he'll be in ATMs. Divide the 23.8 millimeters of mercury by, what number did you say? 760, and you'll have that one in ATMs. Subtract the two, they'll both be in ATM, then you'll have the answer in ATM, which is totally ready to plug into PV equals nRT. I think there's more than one way to do this, but I think that'd be the easiest way.
How do you know how to convert the KPA?
Right here, given.
Oh, okay.
Lauren's.
What? Oh, okay, so 97.8 divided by 101.
0.325. He'll be in ATMs.
I just don't understand. And once you get that number, you convert that into, or is it just already there?
Well, do it. Try it. Right? Why? Well, then what's on top when you do it? Once you get the right P, then you're ready to plug it into PV equals nRT. Right?
Your
RV was 3.75 liters. Trying to find little n. T was 25. One four is 3. And then we can finally convert. What was it? I think it was 1 to 1. Plugged into the ideal gas law. Did you get 64 as a molar mass for ammonium nitrate? 64? You did? Okay. So you got about 9.2 grams is the final answer? Excellent. Okay. Yeah, somewhere close to 9. Somewhere close to 9, depending on how many digits you're carrying in your calculator. That's a long one. They can't get much more complicated than that. That's why they're in the review. So we're about out of time. But give these problems a shot, and we'll work on them and try to make you comfortable with them. The help session. Come by between 11 and 1. Come by anytime tomorrow, Tuesday, pretty much from 8 a.m. through 5 p.m. Right. Yeah.
we have lab too?
Of course.
Wait.
Tuesday or Thursday, whatever day you go. But you can